All right, so with this video, we're simplifying square roots, but these square roots have numbers and variables in them. Okay? But don't be freaked out. It's going to be okay. All right, we're going to go through these. And again, if you need to see my video of how to break down just square roots in general, there's another video, and I hope you'd go watch that. But now we'll do 11 through 14. Okay? So in this page, again, I'm just going to rewrite the problem right next to it. So 75x squared y. All right, let's worry about just the number right now. Just the number 75. Okay? So 75, what numbers go into 75? Well, I know 5 and 15, I believe, go in there. 5 times 15, yep, that's right. Okay? So 5 and 15 go in there. And then we can break down 15 into 5 and 3. And wouldn't you know it, there we go. I have all prime numbers, and that's what we want. Okay? And as we talked about in the other video, if I have a pair of the same number, I write it on the outside. And then anything left over, like this 3 here, stays on the inside of the square root. Now, I left a space there on purpose, and you'll see why here in a minute. Okay, so that's the number. Okay, now let's deal with the variables. So it says x squared. Doesn't that mean x times x? Right? X squared means x times x. We know that. And how many x's are there? There's 2. Yes, it's a pair. So just like the numbers, the variables have the same characteristics. If you have a pair of the same variable, you can circle it and pull it out and write it on the outside. So there's x. And then there's nothing left over, so nothing stays on the inside. And now let's deal with y. There's only one of them. Okay? There's one y. So there's no pairs, so I can't pull anything out. I have to leave it on the inside. So I put y right here. So my final answer for this one is 5x radical 3y. And the reason why I was able to pull 5 out is because I had a pair of 5s circled in orange there. I had a pair of x's circled in purple I was able to pull out. But the 3 doesn't have anyone, so I can't stay on the inside. And the y had no pairs, so it stayed on the inside. So hopefully you're starting to see and kind of understand how to do this with prime factorization. All right, let's do it with 64 here. Let me write it off to the side so we have a little bit more space. Okay, so 64, m to the third, n to the third. Okay. All right, now hopefully you see, wait, 64 is already a perfect square. Cha-ching, it's 8. That was easy. So 8 just goes on the outside. All right, and m, okay, I have 1, 2, 3 m's, right, because m to the third. So I have a pair I could pull out right here. I have 2, okay. But I notice that 1 is still inside, okay, because I only have 1 left there, so I need to put a radical here and put an m. Okay, and then let's pull out the n's here. I'll come in between. Okay, so I have 3 n's as well. Okay, 1, 2, 3. And again, I have a pair of them right here, so I can pull out one of them. Sweet. But I do have 1 left over right there. And so I need to write it on the inside. So that's essentially how you do it. So the answer number 12 is 8mn, the radical mn. Okay, we'll quickly go through number 13 here. Again, I recognize 16. Oh, it's a perfect square. Perfect. All right, u to the 4th. Okay, so that means u times u times u times u. And again, we're looking for pairs that we can pull out of the radical. So I have a pair here, so I have a u. And I have another pair, so I have another u. Perfect, so everything's coming out of the radical. This is fantastic. And then we have the v's, which we'll put right here. So v times v times v, because there's 3 of them. And I have a pair I can pull out right here. So v, but I do have 1 straggler right here. I have a v that stays on the inside. Now the only other thing with this problem is you have to combine the 2 u's on the outside, because u to the first times u to the first is u squared. And then v radical v. So there's the answer to 13. All right, number 14. All right, this one takes a little bit more work because, as you can see, 28 is not a perfect square. But I do see that 7 and 4 go into it, and 4 breaks down to 2 and 2. So when I start to write my final answer, I have a pair of 2's that will go to the outside of the radical. And then 7 stays on the inside because it doesn't have a buddy. So 7 will stay right here. All right, now let's deal with the variables. Here we go. So x times x times x. I do have a pair of x's right here. Excellent, so I can pull one out. But notice how I have one straggler right here. So that goes on the inside with 7. Okay, now let's deal with y. So y times y times y. Again, I have a pair of y's right here. Perfect. So they go on the outside. And then I do have one y remaining right here. So it goes on the inside. So that's essentially my answer. I did it in many funny colors. So if I wrote it in one color, it would be 2xy radical 7xy. So that's how you do, look at the page, it's all colorful. So that's how you do simplifying radicals that include variables. So the goal is you pull out the pairs, and then the pairs, you only write one of them on the outside. Any stragglers get left on the inside of the radical.